Hello friends, this video on capacitors and capacitance part 26 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 25 before going ahead with part 26. Now let us try to solve some open circuits. So these two problems which we discussed were based on closed circuits. Now what will happen if you get an open circuit? Now in case of open circuit also, for making our solution easier, what do? We assume an open circuit as a closed circuit. Because even if you have an open circuit, there has to be a potential difference across the two ends if the capacitor is storing some charge when you have an open circuit with capacitor and battery source. And you say that the capacitor is storing charge. That means there is a potential difference across the capacitor, because if there is no potential difference across the capacitor becomes dead. The capacitor basically needs a constant or a fixed potential difference so that it can store charge. So even if we are talking about an open circuit, there is a potential difference across the circuit. So what we do to make our solution easier, we assume that the open circuit is a closed circuit, and we assume that the potential difference of the open circuit is nothing but the voltage source of the closed circuit, from where the charge flow is starting. So then we can solve it in the similar way as we did for closed circuits. So let us look at it. Let us suppose if I have a capacitor in an open circuit. So if you consider these 2 points in the open circuit, there is a potential difference between A and B, because of which this capacitor is storing some charge Q along it. If there is no potential difference between A and B, then there will be no charge in the capacitor. The capacitor will become a dead capacitor. So when I said that we assume an open circuit as a closed circuit for the sake of making the solution easier or to solve it more easily, what did I mean? I mean that let us suppose that the potential difference between A and B, that is, let us say VA minus VB is equal to V. If the potential difference across this circuit is V, we assume a virtual circuit like this. We assume that it is connected to a voltage source, and this voltage is V. That means instead of assuming that there is a potential difference of V across an open circuit, we assume that it is a closed circuit and the source of the voltage is V. Now if you solve it using Kirchhoff's law, then also you will get the same result. This is your positive, this is your negative, so this will make this positive, this negative. So you write your Kirchhoff's equation. You assume that current starts flowing from here in this direction. This is my assumption. So how do I write it? Let us suppose the voltage across this is V. Okay. This will have a positive sign because it is departing from the positive. Okay. I go to this capacitor. So what is the voltage across this capacitor? The voltage across this capacitor will be, let us suppose if it stores Q charge, it will be Q by C1. What will be the sign? It will be negative because it will depart from the negative plate. So this is equal to 0. That means V is equal to Q by C1. Right? So even here also, what is the potential difference? The potential difference of the capacitor is nothing but the charge stored by the capacitor divided by the capacitance. So both are equivalent, right? But if here I took a very simple circuit, but if you have complicated open circuits and if you assume them to be a closed circuit, then your calculation becomes easier, because then you can very easily assume a direction of charge flow and you can apply Kirchhoff's law for closed circuit. Right? Now we will solve a problem on open circuit. Now let us try to solve this problem using the same concept. So what do we have here? We have one source, voltage source, this E. So we have one voltage source and these two capacitors, right? So here this is an open circuit, as you can see. So in the previous slide, what did we see? We assume this open circuit to be a closed circuit. So how do we draw the next diagram is, so we assume that virtually this is connected to this voltage source of voltage, say V. So in this problem, it is given that the potential difference between A and B is 5 volts. That means this potential is nothing but 5 volts. The potential difference between these 2 points, that is
this volts. That is the voltage source which I am assuming here, that is 5 volts. Right? So now using this, let us put the signs. So this source of EMF E, this is capacitance C2, this is C1. So let us apply Kirchhoff's law. So we assume this direction of current flow. So this is my voltage source. Let me draw it this way. This is positive, this is negative. So this will make this positive, this negative. Similarly, this will make this negative, this positive. Right? Because we assume that this voltage source dominates. Now assuming this direction, it is now very simple to write down the equation. So we start with this source. So here we have V. It is departing from the positive plate. So the sign is positive. Next we go to the capacitor C1. What would be the voltage across it? It will be Q by C1. What would be the sign? It is departing from the negative plate. So it is negative. Then we reach the next voltage, that is E. It is departing from the positive plate. So it is plus. Then we go to the next capacitor C2. So the voltage across this is Q by C2. It is departing from the negative plate. So this is minus. So this equal to 0. So from this we can say that V plus E is equal to Q by C1 plus Q by C2. Now let us see what we have to calculate here. We have to calculate the voltage across each capacitor. So basically we will have to calculate the value of Q by C1 and Q by C2 from this expression. So for that we will proceed in the similar way. We will calculate the value of Q from here. So if we know Q, we can very easily find out the value of Q by C1 and Q by C2. Now the value of V is already given here as 5 volts and also the EMF source is given as 10 volts. So let me put those values. So this becomes 5 plus 10 is equal to Q into 1 by C1 plus 1 by C2. C1 and C2 are also given as 1 microfarad and 2 microfarads respectively. So from this we calculate the value of Q and Q comes out to be 10 microcoulombs. Now once I get the value of Q, it is very simple to calculate the voltage across each capacitor. So voltage across capacitor C1 is Q by C1, which comes out to be 10 volts. Similarly, voltage across C2 is V2, which is Q by C2, which comes out to be 5 volts. So even though it is an open circuit or a closed circuit, we apply the Kirchhoff's law in the similar manner with the same convention, right? So now we have solved quite a number of problems based on Kirchhoff's law. Let us look at some other types of problems now. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.